possible. Does that answer your questions?
Yeah, that's good to me.
All right.
Yeah, it's going to be easier when you take it out.
So here we go. Let's talk about vectors. So formal information. Ladies, are we recording?
Yes.
Great. A vector is a directed line segment. Let's see. Hold on here.
I'm going to read this.
Okay.
Looks good.
Awesome. So directed line segment. So I draw it with, oh my gosh, this is terrible. Line segment with an arrow. Notice I've got a dot on this end, and I have a dot on this end. Guys, ladies, back looks down, please, appreciate that. Thank you. All right. It's a line segment, not a ray. In geometry, you learned ray goes on and on forever. A vector does not. So it's got a beginning and an end, okay? And we write it as this notation as a letter with basically an arrowhead over top of it. However, we normally are super lazy in mathematics, and so we tend to just draw essentially a ray, but it is understood by everyone that the vector does not go on forever and ever and ever. It stops right there. We also get lazy when we write our name, or the label for it, and we just tend to do that with half of the arrowhead there. So, being lazy all the time here. A vector is a directed line segment with basically two pieces of information. It has a magnitude, which essentially means its size, and its direction, which means its direction. Alright? The longer the line, then the bigger the magnitude that it represents. The smaller the line segment, the smaller the magnitude. The direction is indicated by the arrow. Okay? Why do we have an arrow rather than just a line segment? Because there's something different between this and this. First one's going up and to the right, the second one's going down to the left. So you have to have the arrow. That's an essential part of a vector. Okay? So you've got a magnitude direction. You also can talk about a vector in terms of its x component and its y component. So there's vector A. At angle theta. We normally talk about the magnitude. So magnitude is absolute value bars above it. Direction, we talk about it in terms of theta. And theta could be, 30 degrees, which pre-calculus students everywhere understand to be 30 degrees above the positive x-axis, or maybe 50 degrees west of north, which everyone everywhere understands that from due north you rotate in the west direction 50 degrees. It could be negative 60 degrees, which we all understand it means this, and so how you choose to describe your angle is largely part up to you. And then your x component and your y component, we would call those like AX and AY. So in this picture here, AX is along the horizontal aspect, and AY is the vertical. And if you notice, I drew those as vectors, and that's pretty common we normally talk about the x component and the y component as actually being vectors themselves, because this is a vector straight in the x direction, it's a vector straight in the y direction. We talked about earlier this week that you can find AX by doing the magnitude of vector A times the cosine of the angle, the magnitude of the y component, or sorry, the y component is the magnitude times the sine of the angle. Also, if you want to find the magnitude and you're given the x and y component, you can use Pythagorean theorem. So ax squared plus ay squared equals the magnitude of the vector squared. And the angle, specifically theta ref, is equal to the inverse tangent of the absolute value of ay over ax. Okay? All that stuff is stuff we've dealt with before, and that's going to help you out here in a minute with your homeworks. Before I talk about addition, subtraction, multiplication, any questions? Okay? Let's keep going then. So, vector addition. Vector addition first. We'll do vector scalar multiplication first, actually. If I have vector A that looks like that, then 5 times vector A would literally mean 5 of those end to end. 1, 2, 3, 4, 5. Where each one of those is vector A. Scalar just means a single number, one piece of information. Okay? So if you have 1.5a, then that's going to be a plus half of an a. So it looks something kind of like that. All right, let's do vector addition. Vector A plus vector B equals vector C. Vector A might look something like that. Vector B, something along those lines. It's a 1, 2, 3 process. Step 1, draw vector A. Step 2, draw B on the end of A. And step 3, connect the beginning of A to the end of B. So following that process, I'll draw vector A. Thanks, Bridger. Then we'll draw B at the end of that A. Very similar to what we did yesterday. And then connect them, the beginning of A to the end of B. And that is A plus B. That's kind of like we did yesterday, isn't it? Where we had to measure them all out and everything. Mm-hmm. All right. Okay, 2 more things. Multiplying by a negative. Assuming that that over there is vector A, negative vector A is the same magnitude but opposite direction. So same magnitude, opposite direction. So in that case, that would be negative A. This one over here is going up and to the right about 2.5 inches. It's going down and to the left about 2.5 inches. And finally, vector subtraction. So if you have vector A minus vector B, what you do is you treat this as adding the opposite of vector B. So A plus negative B. So following our three-step process, we're going to draw A. Got it? Draw negative B. Okay, so if B is down to the right like this, then negative B would be kind of up like that. So there's negative B. And then step 3, connect the beginning of A to the end of B. So it would be something like that. So this would be vector A minus vector B. All right, raise your hand if you have finished homework 37. 1, 2, 3, 4. All right, you 4 can work on 38 or your 10 topics. Everyone else, we're working on 37. It should take about 5, maybe 10 minutes. I'll be walking around answering questions on that.
These are your equations.